Error analysis. Introduction. Today, we will learn about error analysis, a very simple, important concept in measurements and physics experiments. Let's understand this in simple steps. Absolute error. Absolute error equals the modulus of the difference between true value and measured value. Let us know first what is true value is. If you measure a quantity many times, the average of all reading is taken as the true value. If you measure a quantity many times, the average of all readings is taken as true value. Let the measured values be A1, A2, A3, like that up to AN. Then the mean value is, actually it is the true value. AM equals A1 plus A2 plus A3 plus dot 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 up to AN, the whole divided by N. Now the absolute error in each reading is, the absolute error in the first reading A1 is modulus of del A1 equals the modulus of the difference between the mean value and the measured value. The modulus of the absolute error of the second value equals modulus of AM minus A2. Modulus of A3 equals modulus of AM minus A3. Like that, we go up to the absolute error of the nth reading equals the modulus of AM minus AN. A student measures the length of a metal rod 5 times and records the following values in centimeter. So the measured value A1 is 20.2, A2 is 20.4 and A3 is 20.1, A4 20.3 centimeter and A5 is 20.0 centimeter. Find the mean average value AM. This mean average value is the true value. So AM equals 20.2 plus 20.4 plus 20.1 plus 20.3 plus 20.0, the whole divided by 5. So the numerator gives 101.0, the divided by 5 equals 20.2 centimeter is the average, the mean value of all these 5 reading, and this average is called the true value of these data. True value equals 20.2 centimeter. Absolute error in each reading. So for the first reading, the absolute error is the difference between the true value and the measured value, which is equal to 0. And the absolute error in the second value is the difference between 20.4 and 20.2. It is 0.2. And the absolute error in the third reading is the difference between 20.1 and 20.2 is 0.1. Similarly, for the fourth data, similarly for the fifth data, we have to take only the positive difference. Mean absolute error. Mean absolute error is the average of all absolute errors. Del AM equals absolute error in A1 plus absolute error in A2 plus absolute error in A3, like that up to absolute error in AN, whole divided by N. It gives an idea of how much the values deviate from the average. It gives an idea of how much the values deviate from the average. The magnitude of the quantity may lie between AM plus del AM and AM minus del AM. Find the mean absolute error for this given problem. So del AM equals, let us add all absolute error in each quantity, 0 plus 0.2 plus 0.1 plus 0.1 plus 0.2 whole divided by the number of data, it is 5. So the numerator gives 0.6 divided by 5. So the answer is 0.12 centimeter is the mean absolute error. So the length of the metal rod lies between A equals 20.2 plus or minus 0.12 centimeter. Relative error. The ratio of the mean absolute error to the mean value is called the relative error. The ratio of the mean absolute error to the mean value is called relative error. Mathematically, relative error equals del AM divided by AM. This tells how big the error is compared to the actual value. Example, if the real speed of a car is 62 km per hour, but the speedometer shows 60 km per hour, now find the absolute error. It is the difference between the measured value and the true value. It is 62 minus 60 equals 2 km per hour is the absolute value error. Relative error equals the absolute error divided by the true value. So 2 divided by 62 equals 0.032. Percentage error. The relative error expressed as percentage is called percentage error. The relative error expressed as a percentage is called percentage error. Percentage error equals the relative error multiply 100%. Del AM divided by AM multiply 100%. A smaller percentage error means the measurement is more accurate. So, for a given problem, the percentage error is the relative error multiply 100%. So, 0.032 multiply 100% equals 3.2%. Let us continue the previous problem. Let us find the relative error for the above quantity. Relative error equals del AM divided by AM. Del AM is the mean absolute error, AM is the true value. Here in our problem, the mean absolute error is 0.12 centimeter divided by the true value 20.2 centimeter. So the answer is approximately 0.00594. Find the percentage error. Percentage error equals the relative error multiply 100%. We found that relative error is 0.00594 multiply 100%, we get percentage error equals 0.594%. Conclusion. So that's all about error analysis. Absolute error, mean absolute error, relative error and percentage error. Hope it's clear now.